This is R.D. Sharma Solution Class 12, Chapter 15, Mean Value Theorems, VSAQ. Very short answer questions we are taking. If fx is equal to ax square plus bx plus c is such that fa is equal to fb, then write the value of c in Rolle's theorem. Now in this, because we know Rolle theorem, so this first fx has to be differentiated. F dash x is what? This will be 2ax and this will be b, simply b, c will get eliminated. This is your differentiation, f dash x. Now we want x, because when we put f dash x equal to 0, the value of x which will give that f dash x equals to 0, that will be c. This 2ax plus b is equal to 0, that means x is equal to negative b by 2a, negative b divided by twice of a. Now this fa is equal to fb. Put a in place of x, put b in place of x and equate it because it is already given in the question. We'll take a into a square plus b into a plus c is equal to a into b square plus b into b plus c. So you can cancel this c out and just bring everything together with similar terms, that is a. If you take a common, it will be a squared minus b squared. B also you take on one side, so it will give you b, and that if you take b common, it will be a minus b inside. So you'll get a, this is a minus b into a plus b. This is going to be plus b, a minus b equals 0. So you'll get a plus b inside. A minus b can be taken outside. So a minus b, when you take outside, it will be a into a plus b is equal to 0. Now when you take, because you have to put separate terms as 0 whenever possible. A minus b is a equals to b. And here you get a, there are two ways in which you can write. A into a plus b equals 0. So you can have a plus b as minus b, this a plus b is small b, right, is equal to minus b divided by a. This is the one way. Or you can write it as capital A is equal to negative capital B by a plus b. So you have two things here, and that x is already minus b by 2a. So this minus b by 2a, if you see, this x is minus b by 2a, and this is nothing but c only. As I said, this already we found out minus b by a. So this minus b by a is to a plus b. This whole is a plus b. So a plus b by 2 is your x, or c you can call. So this is c equals a plus b by 2. That has to be found out in this Rolle's theorem. This c has to be computed. So this is how you are going to write this one, and then all the steps which I explained needs to be followed and to be written as well. So this minus b by 2a minus b by a has to be equated or replaced by a plus b. That is the whole scenario. State Rolle's theorem. Now Rolle's theorem, Lagrange's mean value theorem, that I have explained it in detail. So I'll just write everything in short just to recall. Rolle theorem, we are talking about a real valued function, and we are talking about a closed interval a and b, that is the domain. The first thing which is required in Rolle's theorem is that function has to be continuous. There shouldn't be any breakages. The function has to be continuous in this domain. It is not required that function has to be continuous everywhere. This domain is very important, and this is a closed interval. The second thing is differentiability. The function has to be differentiable. Differentiable means you don't have a sharp turn in that function if you draw a curve. The first one is closed interval, second one is in the open interval. The third thing, where fa is equal to fb, this is the third condition required for Rolle's theorem. All these three conditions, if they are true, then we say c or x, and this c has to be between a and b, so that you get differentiation of this function, that is f dash x or f dash c equals 0. So this is how you will find it in literature, in your book also, different books, if you're following NCERT or R.D. Sharma. Similarly, this Lagrange's mean value theorem, state Lagrange's mean value theorem. We have function fx, and this is defined, or this is in a and b. This is the domain. So all the conditions are not required in Lagrange's mean value theorem. First one is the continuity, which is required in this interval a and b. The second thing is differentiability, that is the function needs to be continuous. There shouldn't be any breakages, and the graph of the function should not have any sharp turn, very pointed turn. So when you get this, then f dash c is equal to fb minus fa by b minus a and b being the endpoints of the domain being given. So how are you going to write it? This is the Lagrange's mean value theorem for you, right? It's almost equivalent to Rolle's, but with a certain twist, because A and B is required at different points. The value of C prescribed in Rolle's theorem for the function fx is equal to twice of x minus 3 to the power n on the interval 0 to root 3 is 3 by 4. Write the value of n. So normally we used to find out the value of C, but here the value of C is already given. The value at the differentiation of this function is going to be 0. That x or that C is given. So fx is 2 into x minus 3 to the power n. I am taking the differentiation first, f dash x, and 2 you can take out. We can use the product rule for x and x minus 3 raise n. X is one function, x minus 3 raise n is another function. So x, I am differentiating x minus 3 to the power n and x minus 3 to the power n minus 1. Then we have this x minus 3 to the power n, and differentiation of x will be 1, and 2 is already there. 2 is already there. Now you can write this x minus 3 raise n minus 1 as x minus 3 to power n and divided by x minus, and this will be x minus 3 to the power n. Now you can take, this 2 is already there, as I keep on repeating, x minus 3 to the power n, twice of this, and this 2 was already there. So you can call it as C, because the question is talking about C. So let us replace x by C. This is Cn, this is C minus 3, and this is 1, because x minus 3 or C minus 3 raised n is already taken outside. This has to be equated, this f dash 3 by 4, because C is nothing but 3 by 4. So this is nothing but f dash 3 by 4, or differentiation with respect to or putting the 3 by 4 value, and this is equal to 0. So twice of C minus 3, C is 3 by 4, raise n. Here also you have to replace everywhere wherever you find C as 3 by 4, it is already given in the question. So 3 by 4 n divided by 3 by 4 minus 3, this is 3 minus 12 by 4, that is negative 9 by 4. It's negative 9 by 4 plus 1 is equal to 0. So it's quite easy to solve this one. This 4 goes, 3 3s are 9, negative 1 by 3, and that is 1 minus n by 3. This is 2, and 3 by 4 minus 3 we already done. It is negative 9 by 4 to the power n. Now minus 9 divided by 4 cannot be 0. It's a proper value. Whatever you do with n, it will never be 0. 2 cannot be 0. That means in this whole scenario, 1 minus 9 n by 3 has to be 0. That is, 1 has to be equal to n by 3. 3 is n. N is 3. This is what we wanted. This is the solution. So whatever I have spoken is being represented here in the form of a reference solution. Find the value of C prescribed by Lagrange's mean value theorem for the function fx equals to under root x square minus 4 defined on 2, 3. Now there are two questions of this sort which has been done completely and fully in the previous exercise. If you remember, it was under root 25 minus x square, and the second one was under root x square minus 4, and we have solved both of them. So I'll give you a reference. This is the reference solution. If by any chance you have not seen that or visited that particular exercise, you have jumped directly to VSAQ, then my advice is you should revisit the previous exercise. The question number 1.13 is exactly the same question which is being given here, but the solution is already provided to you here. So this is all about this exercise. Thank you so much. Have a good one.